All right, and do not be embarrassed to use a calculator on the multiplying or the adding. That's totally fine. Don't create a bad habit of like looking up some sort of like algebra problem solver, because that's just a bad habit. Like you might as well just learn how to do it by hand because you're not going to have access to those on the test. So let's start with table 2. Do we have an answer for number 6? Over x to the what? All right, agree, disagree. You can just do like a thumb up, thumb down if you want. All right, so let's see. I haven't actually worked it out myself. So yeah, 6 times -3, you multiply like normal, -18. And then you use the product rule on the variables. So x to the -8 plus -3 is the math that we're doing. Does give me -11. And so when you pair that with this, you can't leave that in your final answer, the negative exponent. So rewrite it. If there's no fraction bar, put one in there. The only stuff that moves across it is the stuff with the negative exponent. So that -18 doesn't have to move, even though it's negative, because its exponent is positive. So questions on that? Question, Kaden? When your mom comes back. Table 2, or sorry, table 3. Do we have an answer for number 7? All right, so then let's do it piece by piece. When we're multiplying these out, what can I do exponent on the A, table 3? Well, we're multiplying these terms together, but what we do with the exponents is different. So what's going to be the new exponent on the A? Okay, good. Table 4, what will be the new exponent on the B? 5, good. As 8 plus -3 is 5. Table 5, what will be the exponent on the C? No. So that's -12 plus 7. -12 plus 7. Well, this is a -12, this is a 7, together. It's not going to be 19. -5. So feel free to use a calculator. But yeah, when you have a negative plus a positive, and that negative is like a bigger number, like 12 compared to 7, you keep the sign of a bigger number. All right, so yeah, -12 plus 7, that's like owing someone $12 and only paying them back 7. You still owe them $5. Now, is this going to be my final answer, table 6? What needs to change about it? Good, since we have a negative exponent on it, it needs to move. Does anything else need to move, table 7? No, just the one with a negative exponent. So my final answer is a squared b to the 5th over c to the 5th. Any questions? Okay, so then scrolling down. Let's do some power rule. So like in number, let's do one with more stuff in it. Like in number 10. So we have a term all raised to the power of -4. What does the power rule tell us to do? Anyone that remembers? Good, so any variables, you multiply the exponents together according to the power rule. And the way that I remember that one is that the exponents, like the powers, tell you to multiply the base by itself. So that's how I remember to multiply. That's what exponents usually tell us to do. So then in number 10, everything's raised to the power of -4. So even that 3 is, normally I would treat the coefficients like normal and put this in my calculator. I mean, I guess you still could. Let me pull up my calculator. So I have 3 to the -4 power. Press the fraction button. And that gives me 1/81. Because 3/4 is normally 81. So you move it over the fraction bar and rewrite it as positive. So 1/81 is my new coefficient, but I'm gonna leave the whole fraction bar here. And then I have r to the 1 times -4, which is, what's 1 times -4? Good, -4. And then s to the -3 times -4. What's -3 times -4? And it's a positive 12. All right, are we finished? No, because we have a negative exponent in our answer, so that needs to move. Is it the r or the s that needs to move? The r, because that's the one with the negative exponent. So it moves across the fraction bar. And then rewrite your answer. You could do 1s to the 12. You don't really need the 1 if there's other stuff there. And then on the denominator, I have 81 r to the +4 now that we moved it. Questions on 10? All right, so then do you think you need to see another one like that, or do you think you can try something? You got it? Okay, try 9 and 11 then. Of course, we go over them anyway, but just try those, see if you get them right. It's better to get them wrong now when we're taking notes versus like when you're practicing or on a quiz. So just trying is all I can ask of you. Dylan? Are you telling me 9 or 11? Yeah, you have that answer? No. Okay, okay, then tell me 11. Okay, so let's see. We have this in the parentheses, all raised to the power of -2. So that power of -2 needs to go to everything, including the 6. So my suggestion, when you have negative exponents on your coefficients, I would just type those in the calculator. You could apply the negative exponent rule if you want, but the calculator also gives you the equivalent fraction, which I think will just make your life a little easier. All right, otherwise you move it over the fraction bar, you figure out what 6 squared is, which is 36. All right, so 6 to the -2 power is 1/36. So I'm going to change that in this answer. So on the top would be 1, or I may not even need to write it if there's other stuff there. On the bottom, we have 36. For the x, the rule for when you have a power raised to a power is we do what with the exponents? Multiply. When we have a power raised to a power, we multiply. So it's a common mistake. So I'm sure a lot of other people made those same mistakes. So what's 5 times -2? Good, so 5 times -2 is -10, that's on the X as of right now. And then for the Y, we have Y to the -4 times -2. Which what's -4 times -2? +8. So keep things in your numerator or where they're at until they need to move. Does anything need to move so far? What needs to move? Just the one with the X. So that moves across. On my numerator, I just have Y to the 8th. I mean, you could put 1 Y to the 8th, but same difference. On my denominator, I have 36 X to the 10. Because when you rewrite it, you make it positive. Questions on 11. All right, so not bad. Anyone have the answer for 9, you think? No. All right, so then we'll do that one together. -3 is the power to everything that's in the parentheses. So I really have 5 to the -3, which we'll fix in a second. And Y to the what is it going to be? -6, because it's 2 times the -3 according to the power rule. Everything with a negative exponent moves across the fraction bar. So if there's no fraction bar, pretend like there is one. Does the 5 have a negative exponent? So that would move. Does the Y have a negative exponent? So then that would move. Notice there's nothing left in my numerator, huh? Do I put like a 0 there? No, you just put a 1. But if you run out of things in one of on either side, just put a 1 there as a placeholder. The 5 cubed you can rewrite as positive now, so 5 to the +3 power, which we can figure out with our calculator. And then Y to the 6. 5 cubed is what? Anyone know? So 5 to the +3 is 125. So yeah, you are gonna have 125 in your denominator. If you did it like how I told you earlier, you know, type in your negative exponent, click the fraction bar, and it tells you the fraction. So either way you want to do it, you can apply the negative exponent rule on the coefficients. And the variables. So good, any questions? All right, let's try some with dividing. So we have the quotient rule when we are dividing. What does the quotient rule tell us to do with the variables? Exponent? Subtract. That one I remember because the division sign kind of looks like the subtraction. At least out of all the other signs, that's what it looks closest to. So then let's look at some with more stuff in it, like number 14 we can do together. What's 14 divided by 7? 2. So coefficients you treat normal, but variables you use that quotient rule. So it's going to be W to the 4 minus a -2. What's that? Positive or negative? Positive. If you don't believe me, put in your calculator and see what's that. 4 minus a -2 is a +6. because that double negative turns into add. Do I need to move anything in this one? All right, there's no negative exponents in that one, so that one it's already good. Let me see if there's any tougher ones. Okay, let's look at 17 together. So 17. 15 over 18, that doesn't divide evenly, does it? No, it is a fraction though that can be simplified. So either type it in your calculator and see what the equivalent simplified fraction is, or what goes into 15 and 18. 3. 3 goes into 15 how many times? 5 times. 3 goes into 18 how many times? 6. But of course, you could always check it in decimal if you want. All right, as we subtract these, put them in the numerator like to begin with, and then if we need to move them, we'll move them at the end. So rule is that we do what with the exponents? So a squared, or a to the 2 minus 2 gives me a to the 0, which honestly cancels out, but we could cancel that out in the next step. B to the 5 minus 3 gives me b to the, I think I heard, okay, sorry, I thought I heard 7. All right, b squared, yes, 5 minus 3 is 2. And then c to the 8 minus 9, which is -1. So anything to the 0 power is what? One, so that really just cancels out, because 1 times anything cancels out. B squared can stay. Does the c to the -1 need to move? So move it across the fraction bar. And then I have 5b squared over 6c to the first. Now it's a positive one. You put a positive one if you want. You don't need to write the positive one though, if it's an exponent. Questions? All right. I'll have you try 16 and 18. Questions then? After Dylan. All right, Kaylin, what was that? All right, agree, disagree. So let's see, 36 divided by 12 is 3. So yeah, that could stay in the numerator because 3 would have a positive exponent. X to the -4, there's no x in the denominator, so that moves. Or I mean, it's still x to the -4, but then it will move once we start moving stuff. So here, I'll write it off to the side. And then y to the 8 minus 1, or not -1, 8 minus 7 is 1. Only move the stuff with the negative exponent, so just the x moves. If it's not over a fraction bar, put 1 there, and that's what you get. No, you do not need to write the 1, but I won't count it against you. So question? All right, let's see. Table 6. What did we get for 18? So either tell me what you got, or we can do it piece by piece. Table 6. Okay, so then let's do it now. Alexa, what does -4 over 8 simplify to? Negative 0.5, or what's the equivalent fraction? Negative 1/2. What will be the new exponent on the P anemone? What do you think? Sorry, I can't hear you. One more time. Okay, no. So rule for when you're dividing stuff, the quotient rule, what do you do with the exponent? Class? So if it's p to the 1 over p squared, 1 minus 2 is what? And then close. Negative 1. All right, Alexis, what will be the new exponent on the Q? Positive 3, good, because 5 minus 2 is 3. And then Sam, what will be the new exponent on the R? So Sam, you gotta look at it first so you know it becomes it. Sam, look. Ask your question, look at it. R to the 3 over R to the 10 gives me what? Well, if you complain about not knowing how to do it, do you think sweeping's gonna help you know how to do it?
No, that's.
So look at it now. Class, what's the rule again when we have the quotient rule? When we divide stuff, what do we do with the exponents? So what's 3 minus 10? Yeah. 3 minus 10.
What?
3 minus 10. Positive?
Yeah.
It is not a positive sign.
No. Negative product. Negative.
Negative 7. Now, class, is this how I leave my answer? What's wrong with it? Do I move? What do I move? P to the negative 1. Anything else? R to the negative 7. All right, everything that has a positive exponent stays. So I have negative 1 Q cubed over 2 P to the 1 R to the 7. All right, you could just have negative Q cubed. Either way, you need that negative in there. But yeah, that is it. Question? All right, so instead of tackling the mixed practice notes today, we will just kind of pause there. We'll start with the mixed practice tomorrow. You do have a worksheet that I also passed out to you. You should be able to do like the top part of it. Probably up to where we get to 11. You should be able to at least do 1 through 11. Maybe more if you know your exponent rules very well, but we'll tackle that next part tomorrow. So work up until 12:04, and then you can pack up and line up, but not earlier than that. All right, questions?